first quadratic modeling problem, right? And we had a, let's see, a rocket launch, and we put it in the calculator. Let's see, we had to find the maximum height, which was the vertex. So we put it in the calculator. We calculated the vertex, and the x-axis was our time, and it was the x coordinate of the vertex came out to be 1.41 seconds. Then we found other values of the height for given the time seconds, 1, 2, and 3 seconds, right? Then we found the average rate of change, and it had to be an average because if you look at our little picture, our rate of change changes. It's not a constant slope. Okay, think of it as slope. It's not a constant slope, so we had to take the average rate. Okay, the average rate of change. And that was pretty much it in a nutshell. A lot of details to that. Hope everybody was paying attention, right? Not on their phones. Good. Thank you, Adrian. All right, number two. An object is dropped from the roof of a 120-foot building. How long must it fall to hit the ground? Oh, they give us a little hint here. So, what happens if we just drop the object as opposed to launching it? Again, I always like to draw my pictures first. Okay. I'm going to highlight my quadrant one because that's where all the action happens, right? And instead of my y axis, I use h, right, the height. And instead of the x, I use t for time. Okay, so let's draw a picture first, and then we'll go back to this thing. So I'm at 120 feet. Here's 120 feet. And I dropped an object. Say I drop a watermelon on Mrs. Knuckles' head. Okay, splat. Right on her head. Okay, so what's missing from this parabola that we had in this parabola? Now we got time here because there's, in fact, I think they want us to. Well, we have a vertex. Yeah, 120, right? 120 is our vertex. So our vertex is the height is 120, but my t is 0 because I don't go left or right. There's my vertex. Um, we're missing this part, right? That part of the parabola that shoots up to the vertex. So when we just drop an object as opposed to launching it, we lose that part of the parabola. And that's the velocity part. Okay, that's the velocity part. So we lose velocity from our equation. I can't remember this class. Did we have physics people in here? No, no physics people. My other class, one class I had like half the class was like into physics. Yeah, they were telling me my mistakes and everything. It was great. All right, so we lose a velocity from the equation. Our equation, remember, the general equation, h equals, if we're in America, negative 16 t squared plus v naught or v sub 0 t plus h of 0. So we lose a velocity. Velocity is 0. So we lose this whole middle term. So our function here now is h equals negative 16 t squared. We lost the velocity. So it's going to be plus h of 0. Now remember, the ultimate question here is how long will it take? So they're looking for t. So we got to keep the t. But we do know what h of 0 is, right? And if you can't remember what h of 0 is, always go back here and look at the definition. It's the initial height. And they actually gave us that initial height, didn't they? 120 feet. So I'm going to, for h of 0, the initial height, I'm going to put in plus 120. We're looking for the t, so that stays the same. I need the gravity coefficient, negative 16. We're looking for the time, so that's going to stay. So there's my equation. There's my function. And again, don't forget, this is the y equals key, right? That's my y equals key. So I'm going to go ahead and plug this into my handy dandy calculator. I actually had a student when I was calling these parabolas, you know, making fun of it because of a virus thing. I had a kid come up to me yesterday because he was absent and watched the video. He goes, "What's a parabola?" I had to explain to him it's my idiot joke of making fun of a parabola. All right, so let's plug this into our calculators now. Um, who knows who's been playing with these calculators, right? Even there's even a AP statistics course that uses these calculators. So when you go to use these calculators, I highly suggest first thing to do, go to your y equals button, clear everything out. If you have these plots highlighted, I'm going to turn that one on. See how that's highlighted? You have to turn it off because that's for statistical plotting. You turn it on and off by putting your cursor over it and hitting the enter button because it won't graph algebraically if those are highlighted. All right. So we got our y equals negative 16. And again, please use the negative sign, not the minus sign. Okay. Negative 16, we're using x for t. We're going to square it. And we're going to add 120. Now, again, we were messing with the windows yesterday in our algebra class. So if you want to go to zoom, hit the zoom key, go back to the default setting of negative 10 to 10 for the axis. You're going to go to hit the zoom key, use your arrow keys, and go to zoom standard, hit enter, or you can just use the number 6. And it'll put it back to our default screen and it's graphing our parabola. Is everyone here? Everyone have the same screen as me? She's got a big head that'll never hit the ground. All right. So we enter the function into y1, y equal button, right? Y1. And then we have to adjust our window. When we hit our graph, our parabola is going way up here off the screen, right? And then coming back down. So in some of your worksheets, and even I think on the quiz review, it asks you. It's got a row of. If you go to your window, we can adjust our window. Right now, the x-axis goes from negative 10 to positive 10, and the y-axis goes from negative 10 to positive 10. Also, those are the defaults of the calculator. Okay. Now you could change these to fit your parabola, so you could see the whole parabola in your window. Um, Again, some of the homework and some of the review for the test has a whole series in what do you think those values should be. You don't have to answer those. It's easier just to Think about what's going on here. We're starting at 120 feet. So that's my y axis, right? So I need to start at 120 feet way up here, right? On my y axis. So I'm going to go to my window. My y maximum is only at 10. It's at 120. I'm going to put 200 in there. I want to make sure I see that whole parabola. So I'm going to put 200 in there. I could always make it smaller if it's too big. Then I'm going to hit my graph. And there's my parabola. So that's actually pretty good. And if you look at my picture here, I don't even need the second quadrant, the third quadrant, or the fourth quadrant. But if I'm just going to ignore that what's there and just work in the first quadrant, or you can actually, you could make your x minimum. If you don't want to see this much of that parabola, well, let's see, we can make it maybe around -2, and it'll cut off that parabola. So I'm going to go back to my window, and instead of -10, maybe I'll make this -2. Okay, and see what happens. That actually works pretty good for me. That's a pretty good window. Now remember, you can always go back to your default window by hitting zoom standard, right? So it's okay to play around with your window, and if you get really confused or out there, go back to the standard, the zoom standard, and start over. Okay? So here's my path of watermelon falling on Mrs. Knuckles' head, right? Now, they want to know this time when it hits the ground. And we did the three forms when we were doing graphing a quadratic function, right? We had standard form, vertex form, and intercept form, right? This point right there is the intercept. So I want to know where that intercept is. And that will give me the time. I'm not going to worry about the negative intercept because time can't be negative. That's why I'm not even worried about the second quadrant here. I need this intercept. So I need this in our problem, it's the t intercept. In the calculator, it's the x intercept, right? Because they still call this the x axis. What is my h value or my y value of this x intercept? You guys remember? The x intercept y value is 0. Okay. Remember, the x intercept, you set y equal to 0 and you solve for x. Remember how we did that? Anyway, the y is always 0 because it's on the x axis. It doesn't move up or down. Now, we could try to cheat here. Okay? If you think you can get a number, now this, we can't cheat because it doesn't cross at a whole number. It's pretty obvious. It crosses between 2 and 3. So we can't cheat. So here's 1, here's 2, here's 3. Crosses between 2 and 3. 2 and 3 seconds. If it crossed at a whole number, which some of your problems actually do, you could cheat, go to your chart, and look for the y equals 0, right? Because h equals 0 or y equals 0. And if we had a 0 there, we would know what that x would be. But a lot of time, especially if it doesn't cross at a whole number, we're going to have to calculate it. And we're going to let your calculator do the calculations. So remember, I told you there's all kinds of names for that x-intercept. We call it the solution. We call it the roots. We call it the zeros. There's got to be 100 names for these. Your calculator considers that point as the 0. So we're going to go calculate it. We're going to hit second trace. Now that's on your note card, right? second trace, and we're going to go to number 2, 0. So the second one is 0. And we're going to hit enter. Now, it's asking us for the left bound. So I got to get my cursor to the left of that point. Again, remember, we're trying to get this point. I'm going to zoom in on this. Okay. Remember, we're trying to get this x-intercept this point. So I need to bring my cursor to the left because it's asking for the left bound. So I got to be to the left of this point. Well, I don't even see my cursor on the screen, but I do know where it's at. My cursor right now is x equal 4. Is at x equal 4. So if I look on my axis here, let's see, 1, 2, 3, 4. My x is on the parabola, so it's down here somewhere. So I'm going to bring that cursor. I need it to be under 3. So I'm going to use my left key. Notice that when I press the left key, this number starts getting smaller. And I need that cursor to get under 3. So I'm going to keep pressing that left arrow until it gets under 3. And there it is. Okay, I'm going to keep going. I want to make sure I'm to the left of that point. See, it's asking left bound. And it is now to the left of the point. I'm going to hit enter. Now it's asking me to get to the right of the point. Make a right bound of the point that you want me to guess on. So now I'm going to use the right arrow key, and I'm going to get to the right of that point. And I'm going to hit enter. And then it's asking, do you want me to estimate where that point is? And I'm going to say yes, hit enter again. And there's my t-intercept or x-intercept. It's 2.74. 2.74 comma 0. Okay. So it hits the ground at the time of 2.74 seconds. Easy peasy, right? Now you could do this all algebraically. We can easily do this without a calculator, but it's going to take some time, and you really got to like algebra. Should we do another one? I think we shall. So now you got an example of a trajectory, right, where we shoot it up and then it comes back down, a launch. Then we got an example of a drop. Okay, got a drop. And then the third type of problem. Third type of problem is where you're finding it at a certain height. Okay. And let me see if we have enough time. I'm thinking about if we have enough time for this. I don't think we do either. So we'll stop here. Okay.